Alright, I'm going to show you how to generate a design drawing in Fusion. Basically, if you designed a yo-yo and you want to send it to a machine shop and it's not a traditional yo-yo shop, they're probably going to want drawings and you're going to need to know how to make them. So what I'm going to do here, I'm going to hide everything that I don't need so that I just have one half here. I'm going to go to Design, Drawing, from Design. We're going to start with Automatic, and we're going to go ahead and generate it. It's going to start a job, which is going to finish really fast. And then we're going to hit Open. And we've got our drawing. It's going to give us some initial dimensions, which will be fine to start with. I'm going to try to move things over, if it'll let me. I don't know why it's doing that. It normally doesn't give me trouble with moving stuff around, but I'm just going to pull it out of the way here. And one of the first things I'm going to do is double click in a box. Because this is a micro, it's very small, so I'm going to increase the scale a little. And it gave us a lot of helpful dimensions initially. So we've got our threads marked here, which is good. We've got a few things. It's going to mark some things that you don't need sometimes, like it marked a chamfered edge here. So I'm going to just delete that. I'm going to drag some things out to make them a little more readable so that they're not conflicting with lines. And the first thing I'm going to do is add some tolerances. So I plan on telling the shop here this needs a plus or minus 0.02 millimeters, which is going to have it come in just smaller the inside of the MR85 bearing I'm using. This is what goes around the outside of that bearing. I'm going to keep a nice tight tolerance on that as well. This is the chamfered edge. We don't need that. It did not include the pad, recess, so we're going to go ahead and mark that now. So I'm going to click on dimension. I'm going to grab the outside edge first, because that one's easy to get. And then I'm going to zoom in a little to get, there we go, the inside pad wall. I'm going to go ahead and drag that out. Those don't need quite as precise of a tolerance. And then if you don't already have chamfers So like I'm going to go ahead and zoom in here to show you what I mean. You can see that I added little chamfers on the edges here to break most of the edges. I did not for at least one spot. So what I'm going to be doing is I'm going to add a note. Note. Break all sharp edges 0.1 millimeter chamfer. I'm going to throw that in here just for in general to let them know that if there's anything I did not mark to have an edge break, they can go ahead and break the edges on those. Now it looks good. That's really it. Once you're done, you can export it as a PDF and send it to the shop, and they'll know what to do with it. One more thing I forgot to talk about as I was recording that last video, so I'm going to sneak it in at the end here. I have some tolerance standards that I've made up myself that is not normally how most yo-yos are manufactured. Generally, if you're ordering a C-bearing yo-yo, instead of a plus or minus on the tolerance, you're going to be specifying some fit class standards, basically. So pretend like this is the dimension of a C-bearing post, and you're going to go to tolerances and change it from symmetric to a fit tolerance. And a C-bearing post generally expects a shaft K6 tolerance. So we're going to pick custom here. We're going to pick K6. And Fusion wants to show this denominator here. The shop is just looking for just the shaft tolerance here. So I'm going to pick K6 for both here. So it is now marked K6. And then for the outer rim that's going to surround the bearing, we're going to change that tolerance to a fit tolerance. It's going to be a hole tolerance. And for a C bearing, standard is an H7. And this one, of course, just shows up perfectly fine if I just pick H7 from the drop down, but H7 there. And that is how we would mark a C bearings tolerance.